No. You're not. I didn't think so. That's all. Okay.
Alright, I'm ready. What do you want to do? 78? Alright, use the given data to find the best predicted value of the response variable. Assume alpha equals 0.05. Anybody know what chapter this is? 10! Yay! Alright, so don't forget, if you missed class, you can watch the videos on Blackboard. Alright, so we're trying to predict. Now, in chapter 10, we learned that you can predict using the regression equation, which is this guy, or if the regression equation doesn't apply, your best prediction is y bar, which is the average of the y's. Now, to determine which one you use, you look at who?
The chart.
For who, though? Who decides if you are... No. R. R is your correlation, your linear correlation coefficient. A lot of words here. Alright. If your R is bigger than your critical value, or if R is less than your critical value. Depending on what your R is, that determines what you do. Now, your critical value you get from table A, I think it was A6. Let me bring that up. I'm going to need it. Yep, A6. This is a table that's provided on your test if you need it. Alright, so to use this table, you need your N and your alpha. So, I think they gave us both of those. All right, where's N in our problem? 4 pairs. That's our N. Remember, N is paired data, not every X plus every Y. It's how many pairs do you have. So if you count how many X's there are, that's your N, in your homework especially. Which, by the way, if we run out of review stuff, you can bring up your homework on your computers and ask those too. I'll help you. First, the review sheet, though. Alright, so that's our N, and we also need our alpha, which is, there it is, also given to you. So, N is 4, alpha is 0.05, 4, 0.05, find where those meet, and that is your critical value. So we're going to compare our R value to this critical value. So for our purposes, R was 0.942, and our critical value was 0.9 something. 0.95. Now, that's how you find the critical value. Now, if R is bigger than your critical value, does anybody remember what your conclusion is? Then you have a linear correlation. Linear correlation means you use the line. If R is less than your critical value, then you do not have enough evidence. You might have a linear relationship, but you don't have enough evidence to have a linear relationship. Enough evidence to support a linear correlation. In which case you would use the Y bar. So how do our R and critical value compare here? R is less than our critical value. So which one are we going to use to estimate the Y value? y bar. So y bar, they actually gave that to you in this question somewhere. Oh, there it is. So that's your answer. All right, that was a lot. Are there questions in there? These are your two possibilities. Now, this is the wordy answer. I gave you the wordy answer to help you with your homework. But the short answer, if R is bigger than your critical, you have a line. If R is less than your critical, you use the mean.
Your y hat is your what?
Your mean, the average of the y's.
What does that say, the BOT?
Oh, that's the equation, the regression line. So what's happening here is you have a bunch of data, and they're all points on a x and y axis. So you have a whole bunch of dots here. If those dots are actually in somewhat of a straight line, so like here you see a pattern of a line going up, then you have a regression line, and you use R to say if that regression line is good approximator. If you just see, if it looks like a shotgun went off, just dots everywhere, then R probably is going to tell you that you don't have a line, so you're going to just use the average of the y's. Meaning there's no pattern, so you can't do a good approximation, just average them all.
Can we just do 79 just to clear it here?
All right, alpha is still 0.05, by the way, same dark lettering up above. All right, so what is the best predicted value of y for x equals 6.8? So to predict it, you've got to determine, are you going to use y hat or y bar? Who determines? What do? R compared to critical value. So let's go find our critical value. So if alpha equals 0.05, and we also need n for our table. What's our n? 8 pairs. So let's go to our table. 0.05 and 8. Guess I should save this. So 0.707 is what we're going to compare R to. So how does R compare to our critical value?
It is greater than.
If R is greater than your critical value, who do you use to approximate the Y? The hat one, yeah. You use the line. If R is bigger, that means you have significant evidence. All right, so R is bigger, so we're going to use the line. So we use y hat. Now, how do we use y hat? Well, y hat is equal to 55.8 plus 2.79x. How do we use this to approximate our y value? You know what x is. So plug your x in, and you'll get the y corresponding to that x. When we did y bar, x doesn't matter because there's no pattern. It's like a shotgun run off if we just use y bar. Because there's no pattern, it doesn't matter what x is. Here, there's a pattern. So the bigger the x, more than likely the bigger the y. Or sometimes the bigger the x, the smaller the y. The line dictates what's going to happen. So we just plug our x value in here. And we get the y hat.
71%.
Thank you. right, what else?
81.
81? Is that what you said?
Yes, sir.
Free response, we made it. Notice the first, 80? Were all multiple choice. The rest of them are free response. So make sure you don't just focus on the multiple choice. You also need your free response. You have approximately 25 multiple choice questions and approximately 10 to 12 free response questions. Okay? Free response means you need to do what?
Show your work.
Show your work. Multiple choice, I could care less. I'm sending it through a machine. It's the only way we get final exams graded. All right, the scores on a recent statistics test are given in the frequency distribution below. Construct the corresponding relative frequency. How do you do relative frequency?
Upper, lower,
Nope.
something like that. Do before, divide by all the numbers added.
Very good. Take your total. What's the total in this column? What's our total frequency? Exactly, add them up. The relative frequency is equal to the individual frequency for each category. Take each one separately and divide each individual by the total frequency. What's the total?
I got 35. I got the same thing.
All right, so each of these we're going to divide by 35. Now, relative frequencies in the book were actually determined by two different ways. This would be one relative frequency. If you turn into a percentage, that should also be acceptable. So relative frequency, we can give it as a decimal or a percentage, either way according to our book. So what you're going to do is you're simply going to build a new table. You're going to have your scores, 0 to 60, 61 to 70, and then you're going to write the relative frequency. So 4 divided by 35 is what? Point what?
1143.
All right, 3 decimal places is probably good. 10 divided by 35?
0.28.
Point.
6. 0.28.
And you get the idea? Wait, what? 343. And so on. Are we okay with that?
That's all you do.
Yep, that's all you do. If you want to change them to percentages, that will also be acceptable, but this is fine.
So that's basically the answer.
Yeah.
So you don't have to do it in percent. It's fine.
I'm okay without the percentages because the book goes back and forth between the two. And they didn't specify which way they want it, so. All right, what else? 80? Alright, so 80 gives you scatter plots, and it asks you which of the following has the strongest linear correlation. In terms of a visual, what does it mean to have a linear correlation? You should have somewhat of a straight line. So, strongest means the straightest line. Does this look like a straight line? Not even close, so that one we'll throw out. So between A and B, which of the dots is closest to just one straight line? That's what you need to determine. I would agree. Questions? And that's a chapter 10 question, so you'll see that on your homework a lot. What else? All right, does the following appear to have a normal distribution? Now, there's no picture here. What does a normal distribution appear in term? What does a normal distribution mean about the values, the frequency?
Ascend and descend.
It goes up and then down, like a bell curve. So this is what your frequencies should do. They should increase, and then they should, did they decrease? If they just increase, that means you have this part of the picture. Is that a normal distribution? So, what's your conclusion? No. Now, this is a free response, so you need to show your work. Showing your work would involve saying they increase but don't decrease. That'd be fine. There's a couple ways to show your work. It's up to you how you do it. Just make sure you do it. Is that okay with that one? 83. All right. Without calculating the standard deviation, compare the standard deviation for the following 3 data sets. What does standard deviation describe? Kind of change. We could call it change. That's what it really is, the change from the mean. A more common term would be the spread from the mean, or the variation from the mean. Okay? Now, the more variation, the more it's spread out away from the mean, what happens to your standard deviation? Your standard deviation gets bigger. Everything close to the mean, not much variation, what happens to your standard deviation? It shrinks. So compare these, okay? Now, they tell you the mean is 30. How does the first data set compare to the mean? It doesn't vary at all. So you're right. The standard deviation here would actually be 0. I use sigma. It probably should be an S, though. They don't say this is a sample or a population. All right, what about in B? Here's 30. Some of them are at the mean. What about set C? Are there any at the mean? So how do A, all right, well, A, there's 0 variation. That one's done. How do set B and C compare to each other? Well, we're not asked to calculate the standard deviation. We're asked to vaguely answer. What can we determine based on the data values? Very good. B has less variance from the mean. So, smaller standard deviation. Than set C. Now, it is also important to notice that B and C have the same smallest number and the same largest number. If those were different, it would be a whole nother ballgame. You wouldn't really be able to compare them, but because they're in the same interval, you can compare them. You just look at how far away everything is from the mean.
Would your reasoning just be that set C has the largest standard deviation because it doesn't include the mean? Would you say that?
Yeah, that would work. Same thing, just shorter. I think, yeah. I like words. And yet, I'm a mathematician, not an English person. For a reason. I can't spell. All right. What else?
Can you do number 86?
86. All right. Find the indicated probability. Of the 84 people who answered yes to a question, 14 were male. Of the 73 people that answered no to the question, 12 were male. If one person in this group is randomly selected from the group, what is the probability the person answered yes or was a male? Now, there's a lot of information there. Anybody have a suggestion on how we should organize this? Yes, sir.
Okay, since we were asked to find what the possibility that the person was either responded yes or was a male, we should organize like how many males we have in this sample, right?
Yeah.
So we have those. So we have 12 out of 73 people that said no. So we have 12. Wait, I would add 84 to 73 first, so like I know like how many people total like.
All right, you're right. Let's organize it in a picture though.
Okay.
That way everybody can see what you're seeing. So I understand what you're saying, but let's put it all together. The easiest way, when you have a lot of information, you have male, you have female, you have yes, you have no. Easiest way to organize is to build a table. Okay, this would be a table that you would build here. So first of all, 84 people answered yes. Where would that go in our table? Total for where, though? The yeses. So underneath the yeses, all the way down, put 84. Now, of those 84 people, you know 14 were male. So what do you know about the females then? So you know 70 were female. That may or may not be relevant. I like to fill out the whole table. That's up to you how much you put in here. You could stop when you have what you need. All right. We also know 73 people answered no. Where does that go? Total no's. Of them, we know 12 were male. So how many female were there? 61. And now you can find the totals on the right-hand side, too. How many males were there total? How many females total? 131. And how many total? Hint, if you add down and add across, they should match. If they don't, something's wrong. So 157. Now, probability of yes or male. How do you find an or probability?
Okay, do you add the probability of A and add the probability of B and you subtract the probability of A and B?
Good. These are not mutually exclusive, which is what we had earlier. So you have to do probability of yes plus the probability of male minus the probability of yes and male.
So that means it wouldn't be like 0 if we're taking away from.
Well, what's happening is in the yeses, you have some men. And if you count them again for the probability of male, you just double counted. So let me circle what we're interested in. We're interested in the yeses, and we're interested in the males. So you see there's an overlap? This 14 here, you have to keep from double counting that. This is the formula. If you don't like the formula, you can do the intuitive way. Anybody remember the intuitive method? Nope. You just add up all the ones that you're interested in. Everybody I circled, add them up. Careful though, I have totals as well as data. So don't count the totals and the data, be careful. But let's do the formula because it's pretty. What's the probability of choosing someone who says yes? That's not a probability. Out of 157. Probability of choosing a male? Very good. But then we double counted who?
14.
So the 14 we have to subtract off. Any questions about this? You have a common denominator, so add and subtract the numerators to get your answer. So 96 is what I get if I did that right.
How many would we round to?
If you're doing probability, the book asks you to do 3 significance. So what is the decimal? Anybody get it? 0.611? Okay. If you get more than 1, we know something's wrong. Now, in the answer key, sometimes it'll give you a decimal, sometimes it'll give you a fraction. I accept either one. Just don't round probabilities too early, because if you round them too early, I can't judge whether you were accurate or not. 3 significant places.
If you do the a fraction would be simplified.
Of course. That one can't reduce, can it?
No.
Okay, good. I didn't think it could. Next,
Figure for 84.
84. Empirical rule. Read the directions. Oops. I am recording, right? Yes, I am. Scared myself for a second. Okay. At one college, GPAs are normally distributed. Do you have to draw a bell curve? This is a free response. Do you have to draw a bell curve?
Yes.
Why?
Good point.
You have to show your work. Free response. You have to show work. All right. A mean of 2.4 goes where?
Middle.
Where's your standard deviation go? I have no idea. We'll figure that out in a minute. What percentage of students at the college have a GPA more than 4.2? So we need to mark 4.2. That's somewhere to the right. Now, more than 4.2. Where are we interested in?
To the right.
To the right. So we want this area. That would be the probability of students having a GPA more than 4.2. How do we find that? You're right, we need a z-table, but do we have z? All of these values are x values. So we need to change them to z values. What does 2.4 translate to? 0. We just need to do 4.2. How do you change 4.2 to a z-score?
X minus the mean.
Sigma. All right, x is minus your mean divided by, what was sigma? 0.6. All right, so what is that? 1.8 divided by 0.6? Did I do that right?
3.
I feel like I'm doing a final exam right now. I'm going for 2.5 hours.
How much time do we have?
2 hours and 45 minutes for your final. And will it take 2 hours and 45 minutes? At least 2 hours. That's if you know what you're doing. If you don't know what you're doing, it'll take you about 30 minutes or 3 hours. All right, what do you do with your z-score?
You look it up
Where?
on your table.
All right, z-table. What am I looking up? 3. All right, positive z-score table. And there's, whoops, come on. There's the 3. 0.9987. Is that what I'm looking for?
So,
Where's 0.9987 in my bell curve? To the left. I forgot what I said. 87?
so you're going to 1 minus that.
Yes.
Oh, wrong one.
I thought we were doing the empirical.
Oh, we're doing empirical, and nobody stopped me.
So confused.
Oh, crud.
No, because you said it earlier.
So just.
Like I said, I feel like I'm done with my final exam. I'm brain dead. Well, that was a great practice for the z-score, and we actually have what we need for the empirical rule, too. Let's see how they compare. How about that? All right. Do you want me to erase everything that doesn't work? All right. Well, we don't need that. We don't need z-scores. We don't need z-scores. So we just need a picture. All right. Empirical rule. What do we need to determine?
How many standard deviations?
How many standard deviations do we go out from the mean here?
3.
How'd you know that?
I added 0.6 to it and so I got
We already found the z-score was 3. Z-score is standard deviations, remember? So I didn't waste my time completely. But yes, if you add the standard deviation 3 times, you get to your data value. Now, empirical rule, what are the 3 percentages? Which one are we at? We're at 99.7, but the 99.7 is the middle between both directions. You don't even want the middle. You want the right tail. So if there's 99.7 in the middle, how much is on the outside? 0.3. 0.3 is where, though? 1 minus 0.997 leaves you with 0.003, or 0.3%. I don't know how y'all want me to do this. That is both tails together. Very good. So, by symmetry, too many humps. Anyway, man, I'm just going to start over on that word. Divide by 2. Yes, sir.
Why do we know there's 0.997?
There are 3 numbers per empirical rule, and those are the 3 you memorize. First standard deviation, 68, meaning you go out from the mean, 1 standard deviation either side. Second number is 2 standard deviations from the mean, and the third is 3 standard deviations. So we have gone 3 standard deviations out, meaning if you add your standard deviation 3 times to the mean, you'll get 4.2.
Gotcha.
Do we have to do it that way? I have to memorize, so can I just do it and do it since all day?
No, that's not showing work.
Huh?
No, it doesn't show work. No. Because those percents also, unless you memorized, remember that picture in the book is rounded. So it's not necessarily correct.
I remember it was the Z-score. All of them.
I encourage memorizing the common z-scores. I do encourage that, but just be careful. Sure you show work. All right. Any questions about this one? Oh, by the way, that's what percentage, so to be technically correct, the percentage would be 0.15%. I'm not picky about that, but depends on who's grading your test. I said, well, my students I grade. I don't grade the other students.
Can you grade ours too?
Sorry. All right. What else?
Can we do 96?
Y'all really hate me today, don't you? All right. This is the problem that never ends. I need some sugar. I feel like I'm an advertisement for Chick-fil-A on this recording. All right. There are 2 of these on your review sheet. These are the doozies. We do try and help you a little bit. We give you all possible samples already. So this is not quite as long as what I gave on my test and what you had in your homework. But this is a doozy of a problem. So here we go. 3 randomly selected households are surveyed as a pilot project for a larger survey to be conducted later. The numbers of people in the households were 4, 6, and 10. That's it. There were 3 households. One had 4 people, one had 6, one had 10. That right there is your population. So if I write this down, my population consists of 4, 6, and 10. Okay? Good? Consider the values 4, 6, and 10 to be a population. That's what it means, okay? Assume that sample sizes of n equals 2, meaning they take 2 at a time from this population, are randomly selected with replacement. What does with replacement mean you can do? And then select it again. So if you select 4, you can put it back and select 4 again. So if you look at the pairs here, these are all 9 of the different possible samples of size 2. Okay, you can't miss any here. On the test, I saw a lot of people forget about the replacement and forget to do 2, 2, 4, 4, 6, whatever they were. So it's already listed. So first of all, I'm going to start organizing my work here. I'm going to write down my samples, like I showed earlier. All right, 4, 6, and 10, right? So these are all the samples that they wrote down for you already. But I need to build a table to organize the rest of my work. All right. Ready? All right, part 1. Find the median of each of the 9 samples. How do you find a median? In this case, you're right. You find the middle number, but because there's 2 numbers, the middle is actually the same as your mean. So this is very similar to a problem, the other example in your review, where they ask you to find the mean. I believe that's what it was. Let me check. 98? Yeah, 97, sorry. 97 asks you to find the mean. So most of this is going to be identical on 97, because median of 2 values is just the mean of 2 values. All right, so let's do that. Let's find our medians. So 4 and 4, what's the median? 4 and 6. So they're adding them together and dividing by 2, in case you're confused. 7, 5, 6, 8, 7, 8, and 10. Those are all the medians. We're still on part 1 here. Am I too old? Does anybody else know the song that never ends? Yeah. Yes, I'm not too old yet. Okay. Most of you have no idea what I'm talking about.
How long is the song?
Don't ask me to sing it because it never ends.
But how long is it at the timeline?
Never ends.
You can literally loop it infinitely if you so desire.
Yes, it's awesome. Anyway, right. So find the median each of the 9 samples. Then summarize the sampling distribution of the medians in the format of a table representing probability distribution. I just lost all of you, and I know it. Okay. Summarize the medians in a probability distribution. Here's what they're talking about. Write down your median. You need the probability as well of each median. That's a probability distribution of the medians. Summarized. Now, by summarize, they're saying, look at your medians. What do you see happening a lot in our list of medians? Repeat. Don't repeat anymore. Write each one time. So 4, 5, 6, 7, 8, and 10. I think that's it. Yes. How do you find the probability of each of these, though? How many times they appear divided by what? How many total samples there were. Here's technically what you're doing. Technically, each of these samples had equal chance. If there are 9 samples and each one has equal chance, what's the probability of the first sample occurring? 1 out of 9. Second one? Still 1/9 because everybody had the equal chance. So all of these are going to have the same probability of occurring. Now, for our median, for 4, it only occurred once. So what's the probability of that occurring?
1/9.
The probability of that sample occurring, or 1/9. Now for 5, I think that occurs more than once. So you add them together and you get 2 possibilities, so 2 out of 9. 6 is
Once.
only, yep, okay. So 1 out of 9. And 7 twice. 8 is also twice. And 10 is once. So that's the summary. That is part 1. All of that right there. Here, this is part 1. Free response, you have plenty of room, lots of blank space. Multiple choice, you have scratch paper, yeah.
They get to ask for it, it's only like 1 piece.
We give you 1 or 2. I think I usually put 2 in the stats test, but All right. Number 2, I finished 1, right? Yes. Number 2, compare the population median to the mean of the sample medians. How do you find the population median? Put what in order? What's your population? 4, 6, and 10 is your population. So in part 2, we take our pop, 4, 6, and 10. From that, the median is the middle number. What is it?
6.
There you go. We are asked to compare this to the mean of the sample medians. One way of denoting this is mu of the medians. Mu of m. Words are fine. So what you're going to do is you're going to find the sum of the medians and divide by the total number of medians. You're just averaging your medians. Where are my medians?
4 to 10.
I have 2 4 to 10s. Which one should I add up?
4, 5, 6, 7, 8, 10.
Should I do this one or this one?
That one.
If you do the one on the right, you have to use the formula for the mean of a probability distribution. If you use the one in the middle, you add them up and divide by what? 9, because there's 9 of them. So it's easier if you use this one. Do you need me to remind you about the other formula? It's the sum of the median times the probability of the median. If you want to do that one. Otherwise, the mean of the medians is the sum of the medians divided by 9. Either way you want to do it, you will get the same answer, and it's using the same information. All right, so I need help. Somebody add all those up and divide by 9.
I got 6, 6, 7, so basically 6.65.
6.67?
Pretty much it.
Okay. So what we're going to do is we're going to compare these. What do you say about them?
One is bigger.
They are not the same. Which is good, because this is a median. If you had done mean, what should they be?
The same.
The same. Do you know why, though?
Because ours is the same.
It's supposed to be a good indication.
Good job. The mean is an unbiased estimator of the population mean. So the mean should equal. Median is a biased estimator, so it would not equal the population median here. All right. I think that's the end of part 2. Hold on, let me check. Yes, part 3. Do the sample medians target the value of the population median? Target implies that they are the same. So for part 3, we would have to say that no, they do not target because they are biased. Biased, or you could just say not equal. Was there a question there? Let me go back up and see what 3 said. In general, do medians make good estimators?
No.
No, because of the same reasoning there. So 3 got answered by that again. All right. What else?
What about some 88?
Which one?
Some 88. 88?
All right. 88. Find the indicated probability. Express your answer as a simplified fraction unless otherwise noted. Decimals are fine. All right, if one of the 255 subjects is randomly selected, find the probability that the person drinks root beer. Wow, beer. Anyway, given, remember, given is the vertical line, and after the vertical line is the given information. They are over 40. There are two ways to do this problem. Do you want the intuitive or the formula?
Easy way.
Are you intuitive or are you formula-based? Should we try intuitive first?
Is the intuitive way where we like circle stuff and
Cross out stuff, yeah.
okay, let's do it.
So intuitive speakingly, man, I need to stop. Intuitive method. All right, you are given that the person you pick is over 40. So who are you interested in? Just the people over 40. What about the rest of the data? It does not matter in the slightest. You don't care anymore. Okay? That data does not exist at all once you have a given piece of information. Now, with the remaining data, what's the probability of choosing someone who likes root beer?
30.
There are 30 root beer drinkers divided by how many total people? 85 you said? Yeah. Now that can be reduced, so you do need to reduce it. What is that? 6 over 17? Yep. Is intuitive okay, or do you want me to do the formula?
Maybe 101.
101.
Sorry, one more
Which one do you want me to do?
Yeah.
Well, I've already got 101, so I'll do that one. All right. Use the given degree of confidence in sample data to construct a confidence interval for P. So, P is in between what? Who is the best point estimator of P? No? P hat is the best point estimator. So you're going to get P hat, you're going to subtract your error from that and add your error. This is going to be the interval that estimates P. Alright, a survey of 300 union members in New York State reveals that 112 favor the Republican candidate for governor. Construct a 98% confidence interval for the true population proportion of all New York State union members who favor the Republican candidate. Alright. Can y'all pull anything out of here?
The N,
Alright, what is N?
300.
Okay, what else? Nope, we don't have a sigma.
It's an S.
We don't have an S.
The alpha.
Alpha comes from the 98%. What's alpha?
0.02.
Okay. What else can you pull out? The X? What's X? Very good. Now,
Yeah, it's not X bar.
X is the, well, this is, alright. It doesn't say mean, so it's not an X bar. Now, this is a binomial situation. Usually, anything involving P is binomial, and X is the number of successes. I need you to find P hat.
You need to do this z times sub alpha over 2.
No, that's going to be our error.
Divided by N.
Okay.
What'd you say?
X.
The number of successes divided by the number of trials is your P hat. So, 112 divided by 300. Can somebody give me a decimal for that? Like 4 decimal places though, because we're not rounding until we're done.
0.3733.
Okay? Now we got to find E. How do you find E?
The formula,
Yeah, this should be on your formula sheet. Z alpha divided by 2. my brain checked out. Hold on. There it is. Square root of p hat q hat divided by n. All right, we have our p hat. I can plug that in. What do you want to find next?
If you're gonna find Q,
How do you find q hat? 1 minus p hat. What would that be? 0.6267? Did I do that right?
6267.
All right. And n, what is n?
300.
Z alpha divided by 2. All right, alpha is 0.02. What's alpha divided by 2?
0.01.
Very good. So how do we find Z alpha divided by 2? Z table.
2.33. It was negative and then we converted it to positive.
Very good. So, I'm getting tired. 0.01. You said 2.33, right?
Mm-hmm.
All right. So plug that into the formula, and we have our error. All right, go for it. I don't trust this calculator, so.
What if I want this for .065 is what I got.
Okay, good. So this is our error, and this is our p hat. So now we just need to build our confidence interval. So p hat minus the error is less than p hat plus the error. All right, I guess I should use a calculator and actually add. And there we go. Did it say percentage? Proportion. Yeah, so proportion would just be the decimals. 99? Wait, hold on. This was 101. You asked for 100 too, also, didn't you?
Yeah, but I like the way that 99 was.
Oh, okay, so 99 instead. Are we ready? Assume that women's heights are normally distributed. Bell curve. Very good. With a mean of 63.6 in the middle and a standard deviation of 2.5 inches. If 90 women, what is the 90 going to be? N. Are randomly selected, find the probability that they have a mean height between 62.9 and 64. What symbol are we finding a probability of? A mean. So what symbol? Not mu. X bar. Because this is a sample of women. It's 90 randomly selected women. That's a sample. So X bar. This is what I've been warning you about. What is the major change in this problem compared to all the other probabilities involving a bell curve we've done?
One's a population and one is a central.
Nope, the ones we've done so far was dealing with x. How does x bar change our problem? You have to have the central limit theorem if you want to continue. The central limit theorem requires n greater than 30 or normal. Do we have either of those? Do we have both, really? Oh yeah, we've driven up bell curve. We have both. Okay, cool. So we have the central limit theorem. Now the central limit theorem also tells us how to calculate a z value from an x bar. This is where the major change lies. What happens to your z-score formula?
Isn't it x bar minus u over the standard deviation divided by the square root?
Very good. The central limit theorem is what allows us to have a sigma definition to do a z-score. Without central limit theorem, you don't have a bell curve. You can't do anything here. All right. So what's our x bar that we're converting? Ooh. Good question. What x bar are we converting? We got two of them. Let's draw a picture so we know what we're doing. So we have two x bars. One is 62.9. The other one is 64. And we